Lesson 14 has a lot of new material, and there is a lot in here. So I hope you're watching this video. The first couple problems are review, but 14B, 14C, and 14C and 14D are not review. And it's something you've never seen before. So I hope you're at least watching half of this. So 14A is review of SOHCAHTOA, right? Sine, cosine, and tangent. Now, we use sine, cosine, and tangent when we are finding a missing side. And remember, SOHCAHTOA typically only works in right triangles. Now, sine, cosine, and tangent also have inverse. So we have some inverse of sine, or sine -1, cosine -1, or cosine inverse, and tangent inverse. And we use the inverse function, use inverse when we're finding a missing angle. And I should have put to find a missing angle. So I'm not going to spend a ton of time reviewing this part because I'm hoping that you remember. So an example, I'm going to do, here's a triangle. And this is 90 degrees. I'm going to tell you that this is M, this is 3, actually I'm going to use M. Who uses M? There's Y, this is 7, and this is X. So to find Y, I'm going to use my inverse functions because Y is an angle. So if I was to label this, I'm going to use the two sides, right? That is opposite, and this right here would be hypotenuse. So the sine inverse of 3/7 would equal angle Y. So using my calculator, second shift sine inverse of 3 divided by 7. Now, really quick, make sure your calculator is in degrees when you're using sine, cosine, and tangent, okay? So make sure if you're looking for an angle that your calculator is in degrees. So mine gave me 25.37. Typically I round to the nearest tenth. So I would say that Y equals 25.4 degrees. Make sure you put degrees on the angle you're looking for. Now let's find X. Now yes, I could use a squared plus b squared equals y squared, but for this purpose, I want us to find X using sine, cosine, tangent because it's just a review. So you know what? I can find, we'll do a separate problem. Here's a different triangle. And let's say this is 8, and I'm looking for X, and they told me that this is 57 degrees. So in order to find X, I know that based on this angle, this is adjacent, and this is hypotenuse. So the cosine, I'm using regular because I'm looking for a missing side. So you're using the regular cosine function. The cosine of 57 degrees equals the adjacent divided by the hypotenuse. I like to cross multiply. I think it's the fastest. So 8 times the cosine of 57 degrees equals x. So if you enter that in your calculator, I got 8 times the cosine of 57, and I got x equals 4.4. Okay, so that's a review of SOHCAHTOA. Next part, or 14b, has to do with angles of elevation and depression. So these are almost always word problems. So let's go over what they look like. So an angle of elevation looks like the following. You've got usually the ground and you're looking up, so it would be the angle here. Where the angle of depression is usually an item in the sky, and so you have your line of sight and then you're pointing it down. So please notice the difference when it comes to drawing your pictures. So angles of elevation where you're looking up, angles of depression looking down. So that's how I remember this. This is looking up, looking down. So we are going to do an example of each, and then we'll move on to the new material. So this is a longer section, and I do apologize for that, but this is how the book wrote it. So an airplane, I left out an I. An airplane is flying at an altitude of 3,000 feet above the ground. Pilot sees an object on the ground at an angle of depression of 26 degrees. What is slant range? So first thing is first, draw a picture. So here's going to be my airplane, right? I know that's a super fancy airplane. So here's a line of sight, right, looking straight out. So angle of depression should look like this, and they said this is 26 degrees. Okay, so draw your angle of depression first. I know it said that the plane is 3,000 feet, right? We measure that straight down, which would mean that this right here is the ground. Okay, so it's 3,000 feet above, and you're trying to find x, the slant range, and so you're looking for this. Okay, so in order to find that, I'm going to make my 90-degree angle, so I know that x represents the hypotenuse. Well, I'm going to need to find that angle right there. So 90 minus 26 equals 64 degrees. So I know this angle here is 64. So I'm looking for x, so I'm going to again use the cosine of 64 degrees equals the adjacent side divided by hypotenuse. Now I'm going to cross multiply. So x times the cosine of 64 degrees equals 3,000. So then x would equal 3,000 divided by the cosine of 64. And that is what I'm going to enter. So I'm going to enter that in my calculator, and I get that x equaled 6,843.52 feet. So the reason he wanted the slant range is that's the distance between the airplane and the item on the ground that he saw. Okay? So that is an example of the angle of depression. You can guess what we're going to do next. We're going to do an example of the angle of elevation. So a man 6 feet tall is 200 feet from a tree. And he measures, and they have tools for this, the angle of elevation to the top of the tree is 11 degrees. How tall is the tree? So again, draw a picture. So I've got a man, and I know that he is 6 feet tall. So this one is a little tricky. Here's the ground, right? Here is my tree. Okay? Now, when that man looks straight across, that's his line of sight. So you're not drawing it from the ground. You're drawing the angle of elevation from his eyes. So I know that this right here is 11 degrees, and I know that he is 6 feet. So they want to know how tall the tree is. So they're looking for this whole thing. All right, so here we go. Now, notice how I've drawn this. They're looking for the height of the tree, but I know from here to here, so if this helps, let me redraw that. From here to here would be X. But from here to the ground, right, is 6 feet because he's 6 feet tall. So I have to solve for X. So I would have, I have the opposite, I have the angle, and I have this bottom piece. So in order to set it up, and I know the ground, I know this length right here is 200 feet, right? The distance from him to the tree. So I'm going to use tangent. Of 11 degrees equals the opposite over the adjacent. So 200 times the tangent of 11 degrees equals X. So tangent of 11 times 200, and I get X equals 38 point, I'm going to round, 9 feet. But that was just X. So to find the height of the tree is 38.9 plus the height of the man, and I should get 44.9 feet. So that one was a little tricky because I had to take in consideration the height of the person. All right, those are possibly review from geometry. The rest of this section I should probably put in a separate video. And I am going to put this in a separate video, so I will actually link both of them because this next portion is the part that is not review. Okay, so I'm actually going to pause it here.